All right, how do we draw or recognize constant speed on the test Monday? All right, Jose did this. Okay, so if Jose did this, all right, nothing wrong with that. How does he label his axes? D and T. Okay, anybody draw it a different way for constant speed? Is the only way we drew it? Can we draw it a different way? Velocity and time. Now Jay has said, which is correct. So if we draw it velocity and time, how do we draw it with velocity and time? Not the curve. That's acceleration with the curve. How would it be to show constant speed of its velocity? That's right. That's the flat line. All right, that would be constant speed. All right, so. All right, so for the next one, average speed. What would average speed look like?
Like going up and go up.
Okay, so that up, down, weird stuff would be average. So how do you label your axes? D and T. Everybody okay with those two so I can erase and draw the next two? Okay, so for acceleration. All right, how would I draw acceleration? I heard a curve. So I heard a curve and I heard a straight line. So for the curve, how am I going to label my axes? D and T. And for the curve, how am I going, or sorry, the straight line, how am I going to label it? B and T. Okay. And so for deceleration,
It's flipped.
it's flipped. Okay. Okay. So number two. What would you do there to solve for velocity on the test Monday if I asked that? What formula would you pick?
Meters over. No.
Okay. So O'Snell said velocity over time. So if it's velocity over time, what's it equal to over here? It's equal to A. Okay. Now the formula on your sheet is A equals VF minus VI over T. But you only asked to find how many velocities? One, so O'Snell squished it into one V. Okay? Yes. All right, so given that, what's our time going to be? 8. What are we solving for? We're solving for velocity. And what's our acceleration? 12.4. So what do we do to solve? We cross multiply 12.4 times 8. Okay? So 12.4 times 8. I got 99.2. Anybody else get that? Okay. And again, if you have a second here and a second here, what happens to them? They cancel out. Okay? So you get 99.2 meters over seconds. All right, and then I gave us one displacement. All right, I walked 3 miles north and 2 miles east. So if I go 3 north and 2 east, all right, what do I do? The Pythagorean theorem. So we're looking for x. So 2 squared plus 3 squared equals x squared. So 4 plus 9 equals x squared. What's that, 13? Equals x squared. Square root of 13. What's the square root of 13? I got 3.6. Anybody else get that? So 3.6 miles. All right. Questions about that? And I should be opening 2 for y'all. So, any questions? Okay, y'all be on loud today about it. All right, so y'all did homework for me last night?
Yes.
1 to 14?
Yes.
I'd like to see it.
Wait, what? Yeah, homework?
Here you go.
This?
1 to 14.
Oh, I did the whole thing.
Fabulous.
But I didn't even know what I was
Okay, well, I'll give you credit for the 1 to 14.
Thank you.
Pick it up.
Play breakfast. We were yesterday, huh? Okay. What do you do in the play?
You play the tree.
One of the Lord's girls.
He plays with the tree.
No.
I didn't realize there were a lot of trees in Oklahoma.
I don't know, it's still finished.
1, 2, 3, 4, 5, 6, 7, 8, 9 missing. I get it. Trevor.
Oh, I thought it was.
Right, you guys out of it. It's in like 11 and 13.
Yeah. I have a question
Yeah.
about it though.
What about it? We're gonna
Well,
go over it.
yeah, going over.
Yeah, we're gonna go over it. Partner's got his.
I took off.
That's you.
I'm getting the full
Were you here yesterday?
I can't get these off.
Now, hopefully that means, since you're already here, that means you'll turn it in. Kyle?
They need to come on.
Kyle?
And he's really trying to.
1 second.
Oh, stay home, put them on my desk. I don't care. I don't like you don't turn it into me, so your name doesn't have to be on it. Good. Good. Are you?
Yeah, you heard that? Forgot.
Okay. It's not here. It's not here. Obviously, it's not here.
Come on. That's how you can go drop it off. 8. Well, we better make money, bro. They're gonna be crazy, but.
Alright, so if we look at what you got, because I know some of you've got questions based on what Najee said. Let's see what kind of questions you have, and then we're going to finish it, and then we're going to move on and talk about forces today. I've got a couple things to hand back to you, because the only thing I've not finished grading is your lab from yesterday. The speed lab and the openings. I'm thinking about handing back. Yes, yes. They're done. The only reason I don't hand them right back is I let people like Liliana just handed hers in. I usually give people about 2 days to get them in because once I hand those back, I don't take openings again because people will just copy other people's openings and hand them in.
Do you have partners on that lab?
Not really because everybody chewed their own gum. So the only thing people did is they could ask other people about how to do the calculations. All right, number one, what is a frame of reference?
The object used.
Okay, it has to be a stationary object, or it appears to be stationary or not moving. All right, so in 2A, what was the stationary object you could have picked? Sidewalk is fine. All right, did anybody pick something different? What did you say, Isella? Okay, all right. Letter B, what did you pick there? Aisle. All right, and in C? Window. All right. So you're on the you're on plane taking off. The window really won't work.
The track. Yeah.
All right, the road would be fine. The track or the runway on the airport ground would be fine. But you can't use the window. It has to be something outside of the plane that would be stationary. Okay, you can say the ground, you can say the earth, you can say the airport. Some object that's at the airport that's going to be stationary, but it can't be the plane itself. All right, the most common frame of reference is the earth. Simply because most of the objects y'all name are always attached to the earth because y'all usually say things like road, tracks, trees, buildings. They're all attached to the earth. All right. What's the difference between distance and displacement? That's right. Distance is always added together. Okay. So the biggest thing is with distance, you always add, and displacement is always between the start and stop. So what Diavian said, there's nothing wrong with. I was just trying to shorten it a little bit for you if you didn't have that one filled in. Okay. So distance, you always total or add, and then displacement is between start and stop. So a lot of times you're going to subtract or use the Pythagorean theorem. So in number 5, what is your distance? 120. And what is your displacement? 20. And the units on both of those would be what? Miles. All right. What does it mean to say you have constant speed? Same speed, or it's not doing what? It's not changing. All right. So a constant speed graph we drew just a minute ago. Anybody want me to draw that again, or are we okay with that? Okay. Number 8, your distance would be 105 kilometers. Number 9, you would have a speed of 62.5 miles per hour. Number 10, you would have speed equals total distance over total time, or just speed equals distance over time. So a number 11, is this one you said you wanted me to do, Nigel? Okay. So since it tells you a bicyclist goes on a ride and travels 3 miles in 20 minutes, and then you ride 4 miles in 35 minutes, and you rest, and then you ride 15 minutes and you travel, you want to find the average speed that the bicyclist goes. So in order to do that, you have to take the total distance that you drove over the total time it took you to do that. So his speed has 3 miles plus 4 miles. We rested, and then we did 5 more miles. So for his time, he did 20 minutes plus 35 minutes plus 15 minutes of rest. Even though that's rest, you have to include it. And then plus the 30 minutes that he did after he rested. So he did a total of 12 miles, and it took him 100 minutes to do it. So his speed was 0.12 miles per minute. Does that make sense? All right, number 12. What is velocity? Speed with direction. All right, how are speed and velocity different? Speed does not have direction. You don't have to list whether it's south, west, east, or any of that stuff. All right, so number 14, for finding the velocity, it would be 57.1 miles per hour east.
Did you say what 9 was?
9 was 62.5 miles per hour.
And 8.
And 8, 105 kilometers. You need me to do either of those?
Yeah.
Yes, which one? All right, so number 14, you're finding velocity. Okay, so velocity is equal to distance over time. So we're looking for V. So what's the distance, number 14? So we put 400 for distance. What's the time? So velocity equals, when you divide, you get 57.1. And then your unit will be miles over hours. Now, this is the part you have to remember, because you're finding a velocity. You have to write the direction, and the direction in number 14 says east. So you got to write east. Hey, Ms. Burton.
Hey, what is your plan of period?
First.
Oh, obviously, but I keep coming by. You know what? Is this juniors?
Mostly.
Can I just put a quick?
Sure. Talk to them.
Since I'm down here, guys, I'm not sure if you noticed. Hopefully, you have by now that you will be taking the ACT. Some of you will be starting on February the 20th. Throughout that week, different students will be taking it for different days. That is a college entrance test. That test counts. You can submit your scores to colleges for a mission. So please take it serious. In order to help prepare you for that test, we are giving an ACT boot camp next Saturday. I have mailed home last week, everybody a flyer to inform you and your parents about this boot camp. Please take advantage of it. It is a 4-hour free boot camp for you. During this boot camp, you'll be learning, basically it's a refresher. It's a refresher course for you. Because of some of the questions that may be on that test, you may not have seen it since your freshman year. So it's going to be set up. You're going to be going to 4 different classes, 5 actually, but the way you'll be tested in science, you'll be tested in math, you'll be tested in reading and language. And then you will go around to a study skills class so we can kind of give you some insight to how to maximize your score. Please come. We're basically begging you to come. Not only will you get to kind of get that refresher, you also get things if you come. If you come, you'll get breakfast and lunch that day. You will get 1 homework pass. You will get attendance makeup for 4 classes.
I honor all of Miss Burton's incentives, by the way. I honor them all.
And you will get your lowest test grade in 1 class will be dropped. I will give y'all a ticket and you have to just give it to your teacher, as well as a $5 gift card to Chick-fil-A. So again, we are begging you to come. And the reason why we're doing all this is because we know it'll be beneficial for you to actually come to make sure you are prepared for that test. During the study skill pieces of it, we're going to talk about the layout test. So you're going to know how many questions and how many minutes that you have in order to answer each question. Please make every effort to come. In order to register, you can do 1 or 2 things. You can find this paper at home, just open up your Snapchat app, scan it, and it'll bring your the Google form up, or you can come by my office and do it. Please, please, please make sure you're there.
Oh, is it on Saturday?
It is a Saturday. It's from 10 to 2. You're done after that.
This Saturday?
No, next Saturday. Next Saturday. Yes. Come by my office and I'll put some extra ones up on my office door.
It's gonna be all in the summer.
Cool.
Is it gonna be like all in the summer?
Yeah, similar. You
sent that in the mail too?
Cool.
You sent that in the mail too?
Yes, I send it home to everybody. All the juniors should have gotten, as long as we had your address correct on file, every junior I send home. Thank you so much. And then I come back.
Okay.
Wait for you. Thank you, Ms. Walk.
You're welcome. All right. Everybody good? I mean, we have enough tests in here. I don't mind doing the incentives. All right. So we did 14. Which other one did you say?
Oh, I said 8.
8. All right. So 8 asks you to find how far. What is how far?
Okay,
Is that speed, distance, or time if it says how far? It's distance. Okay. So you can either use your velocity formula or you can use your speed formula because they're the exact same formula. It doesn't matter which one you use. The velocity formula is the only one on your reference table. Okay. But they're the same formula. So you choose. Okay. So I'm just going to use this one because this is the one that's on the reference table. Now we're looking for distance because it said how far. If it said how long is time? Okay. So we're looking for distance. When you look at number 8, what is the 35 kilometers per hour? Is the kilometers per hour the time or the speed? So we're going to put it here. Now, if you couldn't figure that out, Nigeria, when you look at it, what is the 3 hours? Is 3 hours time or speed? Yeah. So you could put that there, and then you would have known the 35 had to be the speed. Okay. So you could use that process of elimination to figure out what's going where. Okay? So then take those 2 numbers and do what to solve? Yep. And that's how you get 105 kilometers.
Oh, okay, I just did it.
Okay? Questions about anything else on 1 through 14? All right. We're going to finish the sheet. What time is it? We'll take, let's say, no more than 20 minutes. See how far you can get? And then we'll go over what you've got. Okay? Because I do want to do, if I don't get to friction today, I can live with it. But I do want to do balanced and unbalanced forces today. If we don't get to friction, though, I can cope. All right. If you have questions, I want you to ask me. I don't want you to sit there and not know what you're doing. Audrey, you got your sheet? Yeah, just bring it here, Audrey. You just enter in your homework grades.
Thank you.
You lost it? Come here. Anybody else lose it or don't have it? I know Joseph did. He wasn't here.
Yeah.
One for you and one for Joseph. Thank you, Malik. Anybody else bring me a lab paper back today that didn't turn one in yesterday?
How was that?
All right, the reason you did. You great job, you have to write you will put the 65 and for C. Is okay. Now, you go to solve. One times 150. Now, once you have that, you get that 2 times 7. Okay. Other than indecent.
I just saw it, I was like, oh man.
Yeah, I was like, okay. Apparently, Mine's scrubbed or something.
Because that's the first thing you figure out. What? Man, no, shit.
Yeah,
Oh.
yeah,
And you enjoy the humor too.
yeah, I thought the same thing.
Oh.
Yeah. So I'm trying to think of where it would go from when you go over there. So like on the road, like on the highway, like on interstate, they got south and north, so interstates is important. Airplanes, when they land, airports would have to have directions.
What's the rules for this? Same as add? It's still in the same direction.
It was in the same direction you add.
And the opposites.
Right.
But both of these, right?
Where?
Moving downstream for the first one.
So if they go, so if one goes downstream and the other goes downstream, they go the same direction, so you do what?
Oh, they're going the same direction.
So you do what?
Add.
You add them.
So you got-
And the next
That
one
would be
says
fine.
down and up, so you subtract.
I have a question about that.
Yeah, you'd say 15 minus 10 for the direction, because the upstream is the bigger number, the direction will be upstream.
Also, when you put upstream or downstream.
Yes,
So downstream.
for the direction, it would be the one that's bigger, whatever that direction is.
Exactly.
You got any hall passes left?
Two.
Then yes, you can.
Let's do. Everything we got one?
So I have to put a direction.
Say what now?
Do I have to put extreme?
You would just put that one because there's two different directions. Which direction is bigger, upstream or downstream? And you would put upstream.
Oh,
Well, where'd you put your other? What you said you put them on my desk? Oh, I thought you said you gave them to me.
I'm going to stable.
There's a stapler on my desk.
Wait, no, that's two.
Here you go.
So, I used the velocity speed.
Regarding what?
Let's see.
Are you using the acceleration formula?
Isn't that speed different over time?
Speed equals distance over time. Now A equals BF minus BI.
Why are you slaying? Are you wrong? No. You will have to do it.
I just did. I didn't realize it was a big issue for you.
Yeah.
What are we talking about? Oh, to find the average speed? Yeah, this is total distance plus total time. We didn't. You're still supposed to go to the bottom of the chart to find the total distance. We didn't do. Now, this was finding the average. You were just finding the average. You weren't finding the average speed or anything. You were just finding the average.
Yes. It was via times reality.
See,
See, yeah.
you got more in the car than you get that stuff up. Is that a guess?
It's far.
It's far. Okay.
We can negative this. No.
Really, you still working? She's asleep. Okay, I'm just curious. I know Trevor's out. Mario's out.
Yeah, it was him.
Is him jogging? Is he
Yeah.
actually working?
Am I working?
He's dreaming about his cookies.
I don't feel good. I don't even know if I'm gonna get this new.
Which one?
Wash your hands.
A lot of those hands are like, what is it? Oh, wait, I got this on my hand. What it says, see the girls.
Yes. The famous track song.
Is this true? She really wanted this.
She really ran. I don't know. There's probably vagrant numbers there.
Yes.
You planning as an equal?
Yeah, I was about to go there.
No, apparently he's so fat. Is mine there? Same as acceleration. Mm-hmm. Mm-hmm. I think I need a little more information on the question.
There's only one velocity.
Yeah, like that.
Where we at?
22.
All right, so if you're traveling at 20, and then you're there, this is your first velocity, right? That's VI. And then the bottom of the hill, there. Oh, you said 22.
Yeah, that's 22.
Well, there's two of them number 22, so don't give me a hard time. I
It's
got-
two numbers on it?
Yeah, that's 22 and that's 22.
Oh, alright.
Okay. So Jackie Jordan Kersey ran 400 meters in 80 seconds. At what speed was she running? So calculate the speed in 400 meters in 80 seconds, distance over time. And then we'll read the rest of the question. Is what right?
So that was 5. When we drove away.
The second. Yes. All right, so what'd you get? All right, so now she ran the same thing in 40 seconds. So calculate the new speed. Okay. Now, how do you figure out how much your speed went up? Correct.
I didn't say C.
I know.
I would think of these.
Go ahead. All right, let's look at what you got. And I need to hand back the papers. You might not have finished the whole thing, but made a good stab at it. Here's Mario. Jose. Tyler. John. Start somebody, I think. Let's just pick the one paper. Yep. Trevor. Yeah. Yeah, because I don't want to give you your. Oh, I guess I could. I don't see a reason not to. I don't know who's I'm missing other than Joseph's. He was copying this. I'm not taking his anyway. Because Liliana gave me hers, so I'm going to hand those back to you. Leak. is a all right. Most of you did great on the speed lab. The biggest issues in most of my classes, we did poorly. It was done poorly because we didn't have units on something. And if you don't put your units on stuff, there's not a lot I can do for you. You know, I'm going to whack off a point. So hopefully on the lab you turned in yesterday, there's not a lot of missing units. All right, so let's look at what you came up with on the review sheet, and then we're going to move on to forces. All right, so if we look at what you've got so far, so number 15, if a car is traveling at 1150 miles, you should have 17.6 hours. We okay on that one? I got 17.6 hours. 15. I'm just picking up where we left off. All right, so you should have, I use the same formula. I use velocity. So I had a distance of 1150 over time. The speed is 65. So again, like I told you, I'd put a 1 there if it helps. Cross multiply. You get 65t equals 1150. Divide both sides by 65. Looks terrible. Does that help, Diavion?
Yeah.
Okay. Number 16, give one example of why velocity is important. Remember, velocity gives direction. So where is it important to know a direction? Okay. Things that would be important to know direction on are like highways. How many of y'all drive? Okay. If you get on Interstate 85 North and you accidentally get on 85 South going the wrong way, what's going to happen?
You're going to get lost.
Yeah, but if you go the wrong direction on a northbound highway and you're heading south, what happens if you're you're going the wrong way in traffic and you're going to do what? You're going to have probably die. You're probably going to have a head-on collision. Most of those accidents on highways running at 70 miles an hour, people don't survive those accidents. Okay? Airports. Airplanes come in and there are multiple runways. You have to know what direction a plane is coming in. So airports are important. Trains. Trains are on tracks and they are all running on the same tracks. You have to know what direction the train's going. Those are important places you have to know velocity because you have to know direction. All right, number 18, 25 kilometers per hour downstream and 5 kilometers per hour upstream. All right, 20 on the back. Definition is the rate of change in velocity. 21, 4 kilometers per hour per second. 22, -2 meters per second per second. We drew the graphs 23 several times today. The second number, 22, you have to calculate two speeds. One is 5, one is 10, and you subtract 10 minus 5 and get 5. Number 23, 4 for A, 4 meters per second. B, 3.75 meters per second. And C, 3.75 meters per second. A, you would take the speed distance at the bottom, which is what? 40. So you take 40 over what's the time at the bottom. So 40 divided by 10. For number B, you got to subtract the 2 times on the bottom, and then you got to match those times to the distances. So what distance would match 6? So 25, subtract what distance matches 2? 10. So 25 subtract 10 is 15, and then 6 minus 2 is 4. All right, number 24. To find which one is the fastest, what do you have to calculate in all of them? You got to calculate the acceleration on all 4 cars because it gave you initial velocity and final velocity. So you got to calculate acceleration for all 4 cars. And when you do that, car 1 is going to be the fastest. Okay, car 1 is at 10, and cars 2, 3, and 4 are all 5. Okay, so the answer to B is 5 meters per second per second. All right, number 25, if anybody got that far, is negative 16 miles per hour per second. Number 26 is mass and velocity. And 27, momentum is 225 kilograms times meters over seconds. Any questions?
Okay, so for deceleration, I know you looked at negative, when you got off, is that the answer is right?
If you have the number right but not the unit,
Yeah.
minus 1.
Not the unit, but.
We don't have this.
The negative sign?
Yeah.
In the questions tomorrow, I believe that's a multiple choice question. So one of the answers will be 16 and one of the answers will be negative 16. So you will most likely have picked the wrong answer and we'll get the whole question wrong. Okay. Anybody else? Yes, sir.
Number 27.
Number 27. So the formula for momentum is P equals M times V. So if you're looking for momentum, you're looking for P. And so mass in number 27 is 5. And velocity is 45. So you just do what with those two numbers? You just multiply. Does that help?
I do.
Okay. Anybody else? Question on the review sheet? So do we feel okay with the test on Monday? Okay. So your homework is going to be to study for the test. Okay? And we've done the review sheet, so you should feel good about it now. All right. We're going to switch gears for our remaining 25 minutes, and we're going to talk about forces. So if you will, find your notes. I'm going to start a new unit. That is not what I want. That's not what I want. All right, so back in middle school, it's I don't know. My best guess is you would have probably done this in 7th grade. You might have also done it in 8th, but this should be something prior to 8th grade. You would have talked about forces. Does anybody remember what a force is? Yes? What is it? Oh, yes and no. Okay. Does anybody remember the definition for a force? No? It's any push.
Or pull.
There we go. Hey, I figured somebody would remember something about it. It's any push or pull. Now, usually when I ask for examples of this, you know, people can tell me things like pulling a door open. Okay? Or, you know, something obvious like pushing down on something. But something to keep in mind that are also forces would be like today. A cold front's going to move through, right? So wind on a flag would be a force. All right? A lot of us have electronics that work with magnets. Okay? magnets that are used to open and close something are also examples of forces. Now, it doesn't have to be something that obvious. It could be something as innocuous that you might not even remember, like from earth science. All right, what about the ocean currents, the ocean tide, and the moon? All right, anybody remember talking about the tides and the moon and the cycles? And, you know, we can predict high tide and low tide based on the moon. Okay, there are tables of those things. How many of you have ever gone to the beach and looked at one of those, and you can see, if you've ever stayed in a hotel at the beach, you can look in the room to see when high tide and low tide is for the day. Okay, you can see that. You can see for the whole year. They have it printed because it's predictable. It's a force. Okay, those are things we can see. Now, we're going to talk about two kinds of forces today. All right, and we want to be able to hopefully add them up and find their total by the end of the day. If I've given everybody enough time to write. Okay, so the two kinds of forces we're going to talk about. Nope, not there yet. Scratch that. All right, I'm ahead of myself. This is why I have these typed. It's awful to get old. All right, so a force gives energy. We're going to talk about energy later in the semester too. It's the one topic I hate to teach because it's boring. I can't give you anything to do with energy. Okay, I can't give you stuff to play with. All right, so energy gives energy to an object to cause it to start moving. We can stop it from moving, and we can cause it to change directions. Okay, so we're going to do, I think it's 2 labs in this unit. Can't remember if there's a third one. I know there's 2. All right, in one of the labs, you're going to cause something to start moving. It's going to stop moving on its own. And some of y'all are really going to have trouble with its direction because you're going to use a broom to get it to start moving. And depending on how you hit it, it's going to go all over the place. All right, when I demonstrate it, you can see what I mean. I'm not very good at it. All right, but we can use a force to transfer energy to an object to get it to start moving, to get it to stop moving, and to change its direction. Now, when we illustrate forces, though, and when we use a force has 3 parts. So let's just say that I draw this box, and I illustrate my force this way. Okay? Now, that 50N with the arrow is my force. So what am I trying to illustrate with that 50N in the arrow? What parts am I showing? Yes, ma'am. Yeah. Make sure you take the vest. So what parts am I showing in the picture? What do I have to show when I show the force? What do I have to illustrate?
Direction.
All right, it has to have direction. Okay, what else do I have to have? What else is right here? The arrow is the direction. All right, so that's the amount. Okay, so the amount is the number. Okay, what else is there besides the direction and the number, or the amount? The what? The N is the unit. Okay? And that's going to be a Newton. Do y'all remember talking about Sir Isaac Newton? Okay, Newton is the guy that did so much with forces and Newton's laws. So we use the Newton to talk about force. Now, in the United States, we use pounds. But in science, we use newtons, okay? We only use pounds in the United States. We don't use newtons. Okay, so all of our forces, when we talk about it, and when you draw it, and when we total it, have to have a number, a unit, and a direction. So if I drew a direction, just as a review for the test Monday, is it a vector or is it a scalar? All right, scalar has only a what involved? I'm asking, is a force a vector or a scalar? A scalar is just a number, and a vector has direction. Y'all are supposed to know that from the last unit. So a force has to be which one? A force is a vector. Okay? A force is a vector because what did we just say a force has to have? A force has to have direction. Okay? Everybody with me on that? Yes or no? Okay. Gonna turn the page or no? Yeah. You have written some of what's up here, right? You're not telling me you have to write the whole page. You better hurry.
I'm about done.
All right. So this is the nice part about forces in this topic. We already have some experience. Okay? Because it's just like velocities. Forces in the same direction do what? They go together. That. Okay? So anytime we have forces in the same direction, we're going to add them. So if we have a box, okay, and you see an arrow with them going the same direction, we're going to add. Okay? Does that make sense? Based on what we did with velocities, does that make sense? Okay. You with me, Tyler? Get off your phone. Pay attention. And be a nice day. It's Friday. Even let Eduardo keep his earbud in and Joseph keep his earbud in. Yeah, I noticed. It's being nice today. I'm going to be nice Monday. All right, so when we go the opposite direction, what do we have to do? I heard it out there. We got to subtract. Okay, now these arrows can go two directions. Now, they can point in opposite directions, or change colors there. Or they can pull out, okay? See how they're pointing in opposite directions, or they're pulling out in opposite directions? It doesn't matter which way they draw the arrows. Can you see they're going in opposite directions? Okay. So anytime they're in opposite directions, you're going to subtract. Is everybody with me on that? Okay, when they're in opposite directions, you have to subtract.
What happens if, like, one goes to the left and one goes up?
It won't happen that way. That would be vectors. That would be physics. We're not doing that in here. Okay? Huh? Yes. I mean, that does happen, but that's a physics class, and that's not what y'all signed up for.
I said.
Well, this is a requirement for graduation, so you don't have an option. All right, does everybody have what they need, or do I need to wait? Okay, so we're there now? All right. So what is a balance force? What do you think the word balance sounds like?
Equal on both sides.
They're equal on both sides, okay? So, let's follow along with that with Malik. So they're equal on both sides. Let's see if we can get the other piece before I start to write. That way I don't have to erase or make people who are writing in ink mad. So equal on both sides. Can you tell me about the direction? Okay? Excuse me. Tell me about the direction. So you said we're equal on both sides. Tell me about the direction. Are they going the same direction or are they going in opposite direction? Opposite. Okay. So a balanced force will be a force that is of equal size and it goes in opposite direction. Okay, so the key here is equal size and opposite direction. Okay, equal size and opposite direction. So, if I have this, can we agree that my arrows are in opposite direction? So what do I know I have to do to the size of the force? Okay, they had to be equal, right? So give me a number, Nigel. 4. All right. So if I put 4 newtons here, what do I have to put over here? 4 newtons. Now, what did we say we would do if they were pointing in opposite directions? So we will say 4 minus 4, which gives us what? 0 newtons. Okay? Now, all balanced forces equal 0 newtons. That does not say on. That says 0 newtons. Okay? All balanced forces will equal 0 newtons. Because every time you subtract, what are you going to get? 0. Because every time you subtract, what happens to the numbers? They're going to do what to each other? They're going to cancel each other out. Okay? Are you with me on balance? Yes? Okay. So the opposite of balance to finish our day is called what? What's the opposite of balanced?
Unbalanced.
Unbalanced. And that's where we'll finish for the day. Is to talk about unbalanced and we'll be done. Okay? So what does it mean to be unbalanced? Okay, they're not equal. Okay? So here, the forces are not equal and do not cancel. Not looks terrible. Do not cancel out. Okay? Now, the important part in this is they could go the same direction or opposite direction. They could be the same size. Okay? They could have any of those conditions. They could both be 4. They could both go the same direction. The key to unbalanced is they will not equal what? They will not equal 0 newtons. They cannot equal 0. That's the key. All right. It's not time for the bell yet back there. It's 1:13. I got time to do a couple examples even. Why are y'all? We got time. It's not yet.
1:13.
All right. So let's say that we have a force that is and I have 10, I have 20, and I have 40. Now, what do I have to do? What do I do with these two right here? You add them. So this is 30 newtons pointing this direction. And this is 40 newtons pointing this direction. Now, what do I do with these two? I subtract and I get what? So 40 minus 30 is 10. Now, I need a direction because all forces got a direction. Which direction is bigger, the 30 or the 40? So it goes 10 newtons this direction. That is my answer.
It's always going to be positive, right?
Yes, it'll always be a positive number. Okay? Everybody with me on that? It will never turn out to be 0 if it's unbalanced. All right, one more, and then we'll stop. All right, last one. So what do we do with these two? We add, so we have what here? All right, I hear 90 newtons pointing this way. What do I have here? I have 40 newtons pointing this way. So what do I do with the 90 and the 40? What can you tell me about the arrows? They're going in opposite directions, so we subtract. 90 minus 40 is 50 newtons. Now, which arrow is bigger? The 90, so it's going this way. Everybody okay with that? All right, we'll practice that on Monday after the test. Your homework is to do what? Study for the test. If you're not here Monday, we'll do the test after school, Tuesday, Wednesday, or Thursday.